when I say non-explosive volcanic eruption, what you should be seeing in your mind is lava, like what flows out of Mauna Loa and Kilauea on the Big Island of Hawaii. That's a non-explosive eruption. But now we know that Mount Fuji, like Mount St. Helens, is a totally different type of volcano. It's a stratovolcano because what has actually come out is not lava, not runny, low viscosity, low silica lava that can flow far and wide. Instead, what comes out there is are rock chunks actually, because so much pressure has built as the silica in the magma has clogged up the vent of the volcano. And so today I want you to just fill in these notes about the different types of pyroclastic materials. Now, pyroclastic is a weird word. Clastic is another word for sediment. Pyro, you probably know, fire. So think of it being fire sediments, and that kind of helps you remember. So for the first part there, you want to say that pyroclastic materials are rock chunks of various sizes, and they dominate the landscape at an explosive eruption. Sometimes you'll see a little lava, but not often. So when Mount St. Helens last erupted majorly in 1980, and when Mount Fuji erupted majorly in the 1700s, there would have been rock chunks exploding out. Now, these rock chunks are actually classified by their size. So I wanted to show you their pictures, and then you can fill in the chart. So these are rock chunks called volcanic bombs. And I have read that the largest volcanic bombs are actually the size of small cars. And you might be like, well, Mrs. Fickus, what the heck? Where do these come from? They actually come from the inside of the magma chamber. So every time an explosive volcano like Mount Fuji erupts, the inside gets more and more hollow. That's where the pyroclastic materials are coming up from. And so there's so much pressure building because of that black stopper, which in real life would be silica in the magma, that it can get these big volcanic bombs. Now, they would land closer to the vent of the volcano. Now, these are called lapilli, which is actually a Hawaiian word, which is kind of weird since that's dominated by lava flows. But lapilli actually means little stones in Hawaiian. And I purposely picked this because of the dime. You can see it looks like little pebbles. Now, volcanic bombs and lapilli can certainly be dangerous because they'd be ejected out of the volcano at high rates and would be very, very hot. But what we notice most in pictures of explosive eruptions, it's this. We notice volcanic ash, and if you've ever had the opportunity to touch it, it feels much like the clay sediment. It feels very powdery, and this just absolutely floors me. What this is not a powder. This is rock chunks. These are still pyroclastic materials, fire rocks, so to speak. And this is a testament to just how much pressure builds inside that magma chamber at an explosive eruption. These are rock chunks that have just been pulverized into this powder. So now let's check out your chart. It should actually look like this, which you could probably figure out from the pictures now, that the biggest chunks are called volcanic bombs, followed by lapilli, which means in Hawaiian little stones, and volcanic ash is not smoke. Volcanic ash, they're actually tiny rock slivers. If you see smoke, it's because the heat from a volcano has lit wood on fire, or plant material on fire. So again, non-explosive eruptions, we see lava flows dominate. Explosive eruptions, we see ash, lapilli, volcanic bombs dominate. Those are called pyroclastic materials.